So this graph here, this is the graph of y is equal to sine theta. So we drew this yesterday. Now the period is, that's one wave. Alright, so how far did it go? It went as far as 2 pi. Alright, and the range, how high did it go up? +1, and went to -1. The height and the depth of it. Right, what happens when you plot sine of 2 theta? What happens to the wavelength? Instead of getting twice as long, what does it do?
Sure.
It's half. It's half the length. So what's the period? The length of the wavelength? The length is pi. See that? What's the height, the range? +1 and -1. That doesn't change. Right. What happens if you get sine of 4 theta? What happened to the length of the wave? A quarter, didn't it? So a quarter of 2 pi is a half. So it's a half pi. The range, it goes up to plus, down to -1. Right, so here again is y is equal to sine theta, starting again. So what's the length of it? The period, I'll have range written down there. The period we wrote down before. What's the period? The period is the length of the wavelength. Now what's the range? It goes from -1 to +1. So the range is -1 to +1. What happens if you have 2 in front of the sign? The range is doubled. Is the period any different? Period?
No.
Period is equal to 2 pi. The range goes from -2 to 2. Alright? And what would happen if that was y is equal to 4 sine theta? This will go up to, well, -4 and +4. Okay?